In this video, we shall look at definite integrals and how to evaluate them. Now, this expression which we read integral fx dx from a to b is called a definite integral. Quite simply, it denotes the change in the indefinite integral when x changes from a to b. If you denote this indefinite integral to be the capital Fx, let's say with an integration constant, then the above integral is just capital F evaluated at the upper limit b plus an integration constant minus capital F evaluated at a plus the same integration constant. Now you see the integration constant cancels out, giving you capital F evaluated at b minus capital F evaluated at a. So the point is, as x changes from a to b, the capital F function would change from fa to fb. This range of variation is called the range of integration. A and b are the limits of integration, with a being the lower limit and b being the upper limit. The right-hand side can also be denoted in a following manner. Capital Fx enclosed in a square bracket, and then we denote the lower limit and the upper limit respectively. So these are two equivalent expressions. Let's see how to evaluate definite integrals. An example is as shown. Now we know the integral of 1 over x squared with respect to x is just minus 1 over x. This is from our previous video. Of course, we can ignore the integration constant because they will get cancelled, as we have discussed a few minutes ago. So that integral can be written in a following manner. That is the result. Expanding on it, you get minus 1 over 10, the upper limit first, minus 1 over 1, then the lower limit, and you get 9 over 10. So that is the result. Now let's look at this integral. First of all, we need to use the trigonometric identity to simplify the integrand. Now we know 1 minus 2 sine squared theta is cosine 2 theta. So that means sine squared theta is half 1 minus cosine 2 theta. Substituting this in that integrand, we get the integral, you can take that half out, 1 minus cosine 2 theta d theta. We can evaluate this easily. Half, the first integral is 1 d theta, and that is just theta. When you integrate cosine 2 theta with respect to theta, you get half sine 2 theta. Now let's put in the limits. So putting in the upper limit, you get pi minus half sine 2 pi minus, now putting in the lower limit, you get 0 minus half sine 2 times 0. So this is 0. Sine 2 pi is 0, so your final answer is pi over 2. Integral 3. This is also a very simple integral to do. When you integrate a squared dx, a being constant, you get a squared x. Now integrating x squared, you get x cubed over 3. Now let's substitute the limits. So when you substitute the upper limit, you get a cubed minus a cubed over 3. Now substitute the lower limit, you get minus a cubed minus a cubed over 3, which will give you 4 over 3 a cubed, and that's the answer. Now what about this integral? The upper limit is infinity, so we have to be careful when evaluating this. So we can do the indefinite integral, and we know we're going to get minus 1 over x. Now, putting in the limits, you get 2 and infinity. And this will become, since the upper limit is infinity, be written in the following manner. Minus 1 over x minus 1 over 2. So as x tends to infinity, the first term will go to 0, leaving with just the second term, which is half. And that's the answer. Now let's look at the fifth integral. Again, the upper limit is infinity. And looking at the nature of the integrand, we can use the following substitution, x being tangent theta. Since the variable is changing from x to theta, the limits must also be changed. So let's work out the limits. But before that, dx is secant squared theta d theta. Now the upper limit. When x tends to infinity, then theta must tend to pi over 2, because tangent pi over 2 is indeed infinity. And when x is 1, then theta has got to be 45 degrees, or pi over 4. Let's substitute everything in the above integral. You get pi over 2 and pi over 4 for the lower limit. Dx is secant squared theta d theta. X squared plus 1 is tangent squared plus 1. According to trigonometry, it is also secant squared theta. So that's going to go away, giving you pi over 2 minus or plus pi over 4 d theta, which is pi over 2 minus pi over 4, and the answer is pi over 4. Now let's look at the sixth integral. Again, you have infinity at the upper limit, and we can use the following substitution. U as x squared plus a squared. So du is 2x dx. Now let's work out the limits in terms of new variable u. When x tends to infinity, then u will also tend to infinity. When x tends to 0, or x equals to 0, then u will approach a squared. Putting everything together, the above integral will become infinity for the upper limit, a squared for the lower limit. X dx is half du over x squared plus a squared, according to our substitution, is u, and don't forget that squared. And this is just, after bringing half out, minus 1 over u, because that's what you get when you integrate 1 over u squared. It's just minus 1 over u. The limits, infinity for the upper limit and a squared for the lower limit. And when we write it, we have to be careful. It's half limit minus 1 over u. So as u tends to infinity, minus 1 over a squared. So as u tends to infinity, the first term goes to 0, leaving that half, and minus minus is a plus 1 over a squared. So the answer is 1 over 2a squared, and that's the answer. Thank you for watching.